All right, here we go. Question number 17 from our 0314 homework number 4 in MyLab Math. Again, we have a bit of a word problem. Alvin paddled for 2 hours with an 8 km/h current to reach a campsite. The return trip against the same current took 10 hours. Find the speed of the boat in still water. There's a lot going on here, but what I'm trying to show you over here in the work area here is that anytime you have a travel problem, that's going to involve the formula distance equals rate times time. And so we're going to be able to set up kind of like an Excel spreadsheet here. Once one row is for the trip downstream and the other row is for the trip upstream. And again, this little setup, this technique will work for any travel problem. So we're going to go through and we're going to fill in. There's 1, 2, 3, 4, 5, 6 boxes we're going to need to populate with information. Okay, so let's start with the trip downstream. Now think about this. If you're going downstream, you're going with the current. Okay, so it says Alvin paddled for 2 hours with the current. The 2 hours is time. 2 is going to go here. 8 km/h is the speed of the current. That does not include the speed of his boat. So his rate, which is speed, is going to be the speed of the boat plus the speed of the current. Now the thing is, I don't know how fast his boat goes, so I'm going to have to use a variable for that. Let's say x, okay? So does that make sense? If you're going with the current, however fast your boat goes, the current increases your speed. It's going to increase it by 8, okay? Now notice the distance. They mention nothing about the distance to the campsite, and so I'm going to leave that empty, okay? Next, upstream. The return trip against the current means you're going upstream against the current. It took 10 hours. That's a time. And think about this. If you're going against the current, however fast your boat goes, the current is slowing you down by 8. So here your rate is going to be the speed of the boat subtracted by the speed of the current, okay? Again, they mention nothing about the distance, but they do actually kind of indicate something subtly about the distance, okay? What do we know about the distance upstream and downstream, okay? Think about this. If he traveled, let's assume 10 kilometers. If he went 10 kilometers to the campsite, how far would he have to go to get back to his car? Well, he'd have to go the same distance, okay? So even though they don't mention the distances, we know that they have to be the same, and that means that we can use a different variable, but we can use the same letter for both distances since the distance is the same. And then notice we do have a system of equations. Here we get each row is going to be an equation, 2 equations with 2 unknowns. I'm going to be able to solve for x and y, okay? So remember that we're working off of the formula distance equals rate times time. So for the downstream row, that's going to be y equals x plus 8 times 2. Distance equals rate times time. And for the upstream, it's going to be y equals x minus 8 times 10. Now, did you notice that both of these say y equals? So does it make sense if y equals y, then this equals this? The 2 red boxes also have to be equal. And so then I can rewrite this as 2 times x plus 8 has to equal 10 times x minus 8. And now I can solve for x, okay? Doing the distributive property twice, 2x plus 16 equals 10x minus 80. I'm going to move the 10x this way and the 16 this way. I've got to get all my x's together. That's going to be 2x minus 10x. That's going to be negative 16 minus 80. And then I need to CLT, combine like terms. That's going to be negative 8x. And what is negative 16 and negative 80? They're both negative, so they're going to add and make negative 96. One more step. Divide by negative 8. And x, which represented the speed of the boat without the effect of the current. In other words, that's going to be the speed of the boat in still water without the current affecting it. We're going to use the calculator for that, okay? So again, negative over a negative makes a positive, so I just need to do 96 divided by 8, and that is 12, and that is kilometers per hour, okay? That is the speed of the boat in still water. And if we go over here and look at what they asked for, it did say the speed of the boat in still water was. So that is what they asked for, okay? So I know that I'm done with that answer. Yay. Now, I'm going to take this one more step further just in case you run into a different word problem. Instead of asking for the speed of the boat, they could have said, how far did he go? They could have said, how far did he go? And then this would not be where you stop. This is the speed of the boat. How can I use that to find the distance he traveled? Well, if I come back up here and look at my equations, I can see that the y represents distance, and that means that I could have plugged into either one of these equations for x and calculated the distance. And it doesn't matter which one you plug into, you could get the distance either way. So I'm going to go ahead and find the distance, even though it didn't ask for it, just for your benefit, okay? So the distance would be y equals, and I'm going to plug into this equation here, x plus 8 times 2. X plus 8, x is 12 plus 8 times 2, and that's going to be 8 and 12. Remember, order of operations, parentheses first. 20 times 2, which is 40 kilometers. So if it would have said, how far did he travel to his campsite, that answer would have been 40 kilometers. Do you understand? When you're doing a word problem, you have to read what they ask for and make sure that you find it, okay? So I hope all of that was helpful. If you have any questions or comments, feel free to leave those in the comment section below, or you can text me, and thanks for watching.